All right, good morning, everyone. We're getting ready to start class. According to the clock on the wall, it's 3 minutes after the hour. According to the clock on the computer, we've got 2 minutes till. I'm not sure which clock to follow. We'll follow them both, maybe. I don't know. But today we're going to talk about some stuff that I find amusing. I hope that you do as well. And so we're going to be talking about exponents, roots, and order of operations. So let's just take a quick look here. And let's think for a minute about what is an exponent. Why do we even use them? And I would like to do a demonstration. Would someone like to assist me with this? Perfect. When you are ready, say stop. I'll give you the cue when we start. All right, someone else, pick a number between 1 and 9. 2 it is. 2 or 7? Well, we'll go with 2. All right, ready, set, go. Okay, mathematicians are notoriously lazy. If you look at our world, we try to be the most efficient possible. We try to make stuff happen in the most laid back, relaxed way possible. As a math person, I'm all about the lounging around and thinking for a job, right? If I had this as addition, I have a shortcut for that, right? Because repeated addition is multiplication. If this were addition, I'd just be like 1, 2, 3, 4, 5, 6, 7, 8 twos. So I would rewrite this as 2 times 8. But notice here, I have these funky dots between them. And those could be a star. They can be an X, although I avoid X's. And well, let's put it where it is. I avoid X's at all costs. But no, unless it's scientific notation, I avoid X's because it can be confusing if I'm using the letter X to hold a place in line. So we've got stars, we've got, of course, some A times some B right next to a parenthesis, those kind of things. That's multiplication. Is there a way to represent repeated multiplication? There is. So let's count this. 1, 2, 3, 4, 5, 6, 7, 8. So here we could write this as 2 to the 8th power, which is going to be equal to what? 256 maybe? 512? So I'm just using my calculator. I'm going to say 2 caret 8, enter. And the caret's the funky little hat symbol that's right below the pi key. And so it's 256. This is an example of what we call an exponent. And exponents, the way we look at them is we have some base to some exponent is equal to my x, which is an argument. When I run into exponents, this just tells me take whatever that base is and multiply it by itself this many times. There is a special exponent when we raise something to the 0 power or to a fraction, and we'll get into those another day. To a 0 is 1. The fractions, we're going to do them a different way in this lesson. Once we've mastered that, then we can play with the fraction way. Okay, so now I'm going to go to the original page where we started here, and we use those exponents as a way of shortcutting the system. So here we have 5 to the 4th. That's just saying 5 times 5 times 5 times 5. So that's 625. How do I know that? I teach math for a living, so I'm a little bit fresher with those things than most. I just said 25 times 5 is 125. 125 times 5 is 625. when you do something a lot, you get to know it well enough, you have these shortcuts. That's just your brain having really strong pathways for things to travel on. Now what we're going to do is we're going to look at roots. And roots are something that I find a lot of people struggle with. I'm not sure if it's just the way they're being explained or those kind of things. But I like to think of a root in terms of right here, there's a little 2. Anytime there's not a number, the 2 is implied. For instance, in modern society, do we agree that when we leave the house, we wear clothing? I think that's a happier society, personally. If I'm walking downtown Cedar City, I don't want to see people without clothing. So it is implied that I have to wear clothing if I'm going to leave my home. The same thing goes for this too. If one's not listed, there should be no one standing out front inside your front door telling you, hey, go back in, put on clothes. Unless you're, a child, at which point you have a parental unit to help you with those kind of things. But ultimately, it's implied means we don't specify it every time. So if there's no number there, it's always implied to be a 2. Now, let's go back to what is it? Well, let's draw us a square. Now, for it to be square, we have to have a few definitions be met. One, we have to have all the sides equal to each other. We have to have all 90-degree angles. Those kind of things, right? If I look at this, how many tiles are in this shape? Well, let's go on ahead and zoom in and we can count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And please don't make fun of my art. I took art in college, okay? I'm an artiste. I know what I'm doing. Maybe. If we look at this, the length of one side, if I'm counting this, 1, 2, 3, that's just going to be 3 units. Whatever they are, centimeters, millimeters, feet, yards, miles, kilometers, hectares, whatever I want. That almost looks like 3 to the power of a. I'm going to just erase that so it's not in there. If I take the square root of this, total tiles is 9. The square root of 9, that's going to give me 3. I like to think of square roots as if this shape were square, what would be the length of a side? And that works great for numbers like, I don't know, 1, 4, 9, 16, 25, anything, because here we have 1 times 1 is equal to 1, 2 times 2 is equal to 4, 3 times 3 equals to 9. This goes on forever. Any number squared. What's up? Well, this one's odd and this one's odd. So with that, when I'm doing this, any number times itself is a square. So if I have a piece of plywood that's 5 feet by 5 feet, that's going to be square. That's the goal anyways. We're making some assumptions on angles, but that's what I'm looking at. And when I'm thinking square, I'm thinking area. So when I hear feet squared, well, that's nice when I have a number that plays well. I mean, like 6 squared is equal to 36. That's nice. That's pretty. But what if I don't see it? What if something doesn't play as nicely? For instance, we have the square root of 81. Well, let's do that real quick. If I said the square root of 81, that's just 9 times 9. It's going to be 9 based on what I've said. I'm going to put this little 2 here to remind me of what I'm doing. And now I'm going to break 81 down into pieces using the fundamental theorem of arithmetic. The fundamental theorem of arithmetic states I can represent any composite number as its own unique set of prime numbers. So if I look at this, 8 plus 1 is 9, so it's divisible by 3. That gives me 27 because I'm saying 81 divided by 3 equals 27. I'm looking for the bricks that make up this number. 27 divided by 3 is 9. 9 divided by 3 is 3, and 3 divided by 3 is 1. So now I have the square root of 3 times 3 times 3 times 3. If I want to look at the bricks that make up 81, these are the prime numbers that make it up. Now I'm going to take and I'm going to remind myself, hey, look here, this number is a 2. That's what I care about. So I like to think about it like I'm going to an exclusive party or something. You know, there's someone at the door with a clipboard and they're checking. This says for every 2, one's allowed to come through. For every 2, one's allowed to come through. And we get 3 times 3. 3 times 3 is indeed 9. So this is how I do the square root of a number. Not all numbers play nice. Sometimes you run into the square root of a number like 8. Well, if I look at 8, 8 is the same thing as the square root of 2 times 2 times 2. So for every 2 there, 1 comes out. I get 2 root 2. And that's as far as I go. Anytime it's not a square number, I cannot represent it without rounding it, without playing with it in some way. Now that'll come up later on in what we're doing. Today we're going to talk a little bit about please excuse my dear Aunt Sally. Now, one mistake that's made a lot of times with this is people will write it PEMDAS. That is a mistake because multiplication and division are the same thing. Division is multiplication by the reciprocal. Addition and subtraction are the same thing because subtraction is addition of the opposite. If you follow these in separate order, like multiplication outweighs division every time, on occasion you will get a wrong answer. So notice these are on the same line for a reason. You always want to treat them the same way. Now let's talk about what is a parenthesis. A parenthesis is anything related to grouping. So if I have any type of symbol that can be used for grouping, that counts the same as a parenthesis. Notice I put absolute value on there. I can put other operations. Anytime something is grouped, it's my way of telling everyone, okay, that's the way it works. Now let's have a look at these words here. Here it says, when we combine multiple operations, we need to agree on an order to follow so that if 2 people calculate 2 plus 3 times 4, they will get the same answer. Notice the direction I'm reading, if you followed that pink line as it was forming, went left to right. In the order of operations agreement, we move left to right. When we're unsure, move left to right. Are there times where I can shortcut the system using properties of multiplication and addition? Yes. But ultimately, I want to be into the good habit of moving left to right. So let's have a look at their example here. We have simplify 2 plus 3 times 4 minus 6 plus 10 divided by 2. So in my brain, the first thing I'm thinking is, are there any parentheses? So I'm looking for these, or something like this. Something that groups it. Do I see any grouping symbols here? No, there is none. Okay, well, next I'm going to check for exponents. And the way I know an exponent is I'm going to look and say to myself, okay, so is there a little number like that 2 right there? That's an exponent. That represents multiple times of multiplying. So with that, that'll come next. Do I see any of those in here? No. Then I'm going to go to the multiply and divide step. I'm going to go left to right. When I do, the first one I see is right here. So I'm going to say, okay, 2 plus, I just bring everything else down. 3 times 4 is 12, minus 6 plus 10 divided by 2. Now I'm going to repeat the operation. I'm going to look and say, okay, have I finished multiplication and division? No, because there's division right here. And so now left to right, I'm going to check it. And I'm going to say, okay, that's 10 minus 2. So I have 2 plus 12 minus 6 plus 10 divided by 2 is 5. Now I'm going to go and say, okay, I'm done with multiplication and division. I've done the parentheses and exponents. Now I add and subtract left to right. 2 plus 12 gives me 14 minus 6 plus 5. Now I'm going to say 14 minus 6 gives me 8 plus 5. And 8 plus 5 gives me 13. This is how I do the order of operations agreement. I always go for the parentheses and the innermost. If I have multiple parentheses, I'm going to go for the ones that are inside the most. It's one of those things where it's like fighting a fire on a house. I want to go to the innermost room where the main combustion is, then go to the areas that were affected, and then clear the rest of the house. The same idea. The innermost area where the most active fire is raging, that's where I want to always start. So now let's look at this. We've got here, they want us to simplify. We've got 4, parenthesis 5 plus 2, minus 6, square roots of 9, plus 4 squared. First step, I'm going to go to, and let me erase this, I don't like bad notation. We'll change that. All right, first step, I'm going to look for parentheses. Do I see any grouping symbols? I see this and this. Both of these are grouping symbols. Because see, this is grouped underneath here. On it, my order of operations is left to right. I'm going to start with this one on the left. So now I'm going to rewrite that as 4, parentheses 7, minus 6, square root of 9, plus 4 squared. Now I'm going to say, okay, the square root of 9 is 3. So this will be 4, parentheses 7, minus 6, parentheses 3, plus 42. Oh, that's squared. Yep. That's why my brain was itchy. I knew something was going on there. Took me a second. I'm like, wait, plus 42? Plus 4 squared. Now remember, I'm still going parentheses, exponents, multiplication, division, addition, subtraction. I've done the parentheses step. There are no more grouping symbols here to be dealt with. Everything's been simplified. So now I'm looking for my exponents. So that would be the 4 squared. And so now I can write this as 4, parentheses 7, minus 6, parentheses 3, plus 4 times 4 is 16. Now I'm done with exponents. I do my multiplication and division. So now I'm going to look at it and say, okay, is there multiplication? Well, anytime I'm bumping up against a grouping symbol, that means to multiply it. So there's two multiplication. We'll start with the one on the left. And that gives me 4 times 7, which is going to be 28. Oh, that's not erasing. That's highlighting my issues. 4 times 7 is 28 minus 6 parentheses 3 plus 16. Notice I'm copying down each line. Now, when you are learning math, you need to get used to the idea of killing trees. The more trees you kill, the better you do at mathematics. I will provide you as much paper as you need to understand the math. We will keep ordering it until we run out on the planet Earth. And then we'll just move to slate or whiteboards or whatever the case may be. Where there's a will, there's a way. I don't care if we're scratching it in the dirt. Don't write small. Notice how big I'm writing? And don't try to fit too much on one page. Notice up here, I was fitting a lot in one page. This work is a bit harder to follow than this work down here. Look at this, how much easier it is to follow this work. So keep that in mind. Paper is a limited resource, but for what we do, we're not worried about the outer limit available. So now we're going to say, okay, multiplication still needs to be done. So I have 28, and then I've got 6 times 3, so minus 18 plus 16. Then I'm going to go and say any multiplication. And the answer is no. So I'm to the addition subtraction step. Now I go left to right. 28 minus 18 gives me 10 plus 16. All right, 10 plus 16 equals to 26, and I'm done. This is how we do the order. We go and we just follow. The exponents is our second step. Parentheses, meaning that's a grouping symbol. I'm going to add square root symbol to our grouping symbols real quick. Is something that needs to be dealt with first. All right, story problems. For a rectangle, the perimeter is 2L plus 2W. Now I'm walk from this spot all the way around and come back. The perimeter is the outside of this shape. All right, so we take and we say, okay, 2 times L plus 2 times W. And the reason we say is there were 2 L's and 2 W's. Use this formula to find the perimeter of a rectangle 10 feet long and 4 feet wide. And I highly recommend that you draw a picture. Use so much grief. Plus now I'm forcing my brain right now, I'm forcing my brain to say, look, 10 plus 10. Oh, that's why I got 2 L's. 4 plus 4, that's why I've got 2 W's. And it'll help me to understand the formulas better. So now get into the 2 2 times 4. And that gives us P is equal to 20 plus 8. So the perimeter is equal to 28 feet. This is in one single, not squared, because we're not talking about an area. We're not talking about carpet. We're talking one line all the way around. So it's just a space like this. Notice that one's squared because that's an area. If we're talking about how much air, how much water, how much of those kind of things fits in a shape, that would be volume. All right, write out the mathematical expression that would calculate the answer to each. So here we're going to write this out. This is just practicing our math. Wants me to answer is how much do they pay altogether? That is the question. Now I'm going to look at what. So I want to figure this out. Going to 12 and plug in a 4. And so the amount, so that gives me an amount equal to 12 times 4 gives me 40. So how much did they pay? Others on 300. How much profit did he make? Well, profit is equal to your revenue minus your cost. It is at the end of the day, how much money can I put in the bank? How much did I make? So if I have a taco cart and I'm selling tacos, I've got to pay for the product on it, but I've also got to pay for that space, things like that. So on this, we're going to revenues, how much is in the cash register at the end of the day. It's the total amount of money coming in. To the revenue, 2,300, which is going to be 1,200 plus 300. And this is why parentheses are important. If I do this with parentheses, then I might think to subtract this and then add this as if it's profit. But I paid on both of these in this scenario. Well, Don did anyways. And so we end up with 2,300 and so that's right. Don't do math in your head. It's dangerous. That's why we always double check it too. All right, here we go. Yes, Keely. Number 11, I would love to. Okay, so here we have 4 times the square root of 25 minus 4 squared. I'm going to follow my parentheses, exponents, multiply, divide, add, subtract, and I'm going to say to myself, hey, look, self, this is a grouping symbol. So I'm going to say, okay, we've got 4, 5 minus 16. Because I'm going to go inside that grouping symbol, look for another set of parentheses. I'm not seeing it. I'm going to go straight to the exponent. Now I don't see any multiplication or division inside there. I do see addition or subtraction. So this is 4 times the square root of 9. And then I'm going to take that out and say this is 4 times 3. And so that gets me to 12. That's okay. That's one of those things, the division bars are always curved or straight. Anytime you see that little foot on it, that's your sign that it's asking for a root. But that's a good point to make. Yep. All right, just one moment. We're going to let Ghazi, a volunteer, take over and have some fun.
Who's coaching all this? Yeah. Bless you. Yes. Yes. 4 power 3 or 4 cube. 4 cube equal 4 times 4 times 4. Yes. Yes. 4 times 4, 16. 16 times 4. 16 times 4, 6. 64. 64. Yes. Now root 49. I want to say it's number if I multiply themselves equal 49. I know 7, but if I don't know, I want to divide. Like now, yes, root 49. I can do right 49. Divide by 2, no able, 7. 7. Divide by 7, 1. This meaning 7 times 7. I want to 2, 7 equal 7. Root, yes. Root 49 equal 7. Okay. Now, yes. Look this. 18 minus 12 divide by 3. I want 18, yes. From begin by divide before addition or subtraction. Meaning now 18 minus 12 divide by 3 equal 4. Now 18 minus 4, 14. 14. 14. Now after. Now from left to right, because here number 4, there is minus and plus. 10 minus 3 before. 10 minus 3, 7. Add 5 equal 12. Equal 12. Okay? Now, number 5. This all time, this times. 2 times 3, 6. 6 times 5 equal 30. Number 6. Now, divide and multiplication. From left to right. 10 divide 2, 5 times 5 equal 24. 25. 25. I want to tell 25. Yes. Number 7. Yes, there is now multiplication and exponent. Yes, 2 times 3 power 2 or 3 square, meaning 9. 2 times 9, 18. Number 8. Direct or simplify? I can tell 10 times 10 equal 100. Yes, meaning this 10 over 2, meaning 5, Or root 100, I can do like 100 divided by 2, 2, 2, like, look here, 100 divide by 2, 50. Divide by 2, 25. Divide by 5, 5. Divide by 5, 1. Meaning root 2 times 2 times 5 times 5. I want to 2 every 2 digit. 2 times 2, 2 equal 2 times 5 equal 10. This numerator 10 over 10 over 2 equal 5. Equal now, yes, 5. I can do, excuse me, I can do 2 times 2. I can do 2 square 2 and 5 power 2 and divide every exponent, divide by 2. I can. Yes, okay. This finished. Yes, now anyone need something, I can repeat it. Anyone need? Okay. Oh, no problem. Those people, I am here if you want anything. No problem, Mr. Matt here. Yes. Now, number 9. Now, number 9. Yes, there is exponent. There is 9. Yes. Number 9, I can write 6. 6 minus 2 multiply. I want to open the brackets or parentheses, parentheses. Yes. Beginning 8 minus 6 because 6. 6 minus 2 times 8 minus 6 because parentheses equal 2. Now 6 minus 4 equal 2. Equal 2. Now number 10. Yes. 3 times 1 and 3, 4 parentheses. Add 4. Now 3 times 16 because 4 square equals 16 times 16 add 4 equal now beginning 3 times 16. 3 times 6 18. 3 4 add 4 now 52. Yes, finished, I think. Yes.
Thank you,
You're,
Kelsey. Does anyone have
you're,
any
wel-
questions?
you're welcome. And
As you do your homework, remember there are videos and things available. We do tutoring Mondays and Wednesdays at 3 p.m. If you can't make it to our tutoring, that's just fine. We record it if anyone shows up. Yes, sir. What day? Say again? Monday and Wednesday at 3 p.m. We do tutoring. So if you need additional help, please come see us. Also, you can make an appointment with us anytime. Gazi is happy to assist you, as am I. Anytime I'm not teaching or in a meeting, I am more than happy to work with. And if it's not too challenging, we got it. It's about canvases, it's not. He is a great teacher.